So we have an in-person speaker here, Dr. Aloizio Dasilva, who is also an IEEE leader, has been involved in many of the IEEE Fusion Network technical community, but right now he's the testbed director at a Commonwealth Initiative, Virginia Tech. Does it work? Okay, yeah. So Aloizio has been experimental in many of the successful projects which he has been leading, and he has been a frequent speaker also. He's also one of the co-hosts for the SRS RAN, right? He can speak more about that. It's a very interesting workshop. So with that, I'll hand it over to Aloizio. Thanks.
Thank you again. It's a pleasure to be here after 2 years. But I'm going to go directly to the presentation. Probably I'm going to go to skip the majority of my introduction because a lot has been said, and I'm going to go direct to the point here. Actually, what I want to say here is what is the role of to have an existing and create an all-run facility and platform, right? It's well known for all of us that the monolithic versions of the telecommunication network, the radio access network, has already your own complexity, right? But now with the all-run, the open radio access network bring to us a lot of benefits as well. But together with these benefits, also we get a lot of complexity, right? And this, believe it or not, is really a lot of complexity. And coupling with this complexity, we have a very tight component that is a key component in telecommunication network, that is the radio access network functionality, that basically have been completely virtualized. And the way that we find to solve the majority of this complexity or mitigate this complexity in such a way that we can accelerate the deployment of this new radio access technology in the real scenario in the field is we need to create an environment, right, that allow us to do experimentation, tests, and trials, right? But in the same time, this overall complexity in the creation of this environment, of these platforms that is well known for all of us as test bed, is not an easy task neither, right? I add a lot of complexity as well to create this test bed, this experimental infrastructure platform. And this opens as well a range of possibility. For example, in the research area, right, opens up an investigative space to do a lot of research, mainly now has been discussed in the applicable use cases that is valid for the community. In the spectrum managed systems, system realization, and mainly security, that a lot has been said here. But in the same time as well, we have another scope that is the basic in testing in trial areas that also opens up the testing evaluation space for 3GPP specifications and validations. What I want to bring here to the attention is that the majority of the specification in 3GPP or RAN Alliance today, and Arpit has mentioned this in the previous presentation, right? We spend hours, years doing specifications, and then you produce 30 pages, 100 pages of specifications, but these specifications, they are not at all validated before or released to the public, to the carriers, right? That is, we need to find a way that before release this 3GPP specification to release our RAN Alliance specification, we have an environment where we can validate, experiment, and test this specification to guarantee that the specification, that everything that is written in this paper is really what we want for our roadmap to accelerate the deployment of the radio access technology. Towards to this, okay, what is the role of this infrastructure that we expected? Is basically implement, validate, and test some of these specifications by 3GPP or RAN Alliance or any other standardization group. Also, implement and validate new protocols, architectures along with the standardization work group to validate that. And of course, provide solutions on architecture and system designs, right? And that can be done together with research. Well, my slide is all mess around.
got mixed up.
Yeah. But what I want to show here, this is not the real slide, is that today we have several testbed network infrastructure out there, right? But little of them is capable to bring to the environment this idea of validation, testing, and specifications of the 3GPP and also the Uran Alliance specification before go to the market. Then I have been working in a network infrastructure implementations and testbed infrastructure that is called Commonwealth Cyber Initiative, XG Testbed, that is basically located in the Washington, D.C. metro area. And we try to bring together this perspective that I mentioned in the introduction, right? The first one is about research. Experimental research has a platform that can enable experimental research to create new protocol, to validate new architectures, and to develop new algorithms that can be used and embedded in commercial equipment. And the second niche is that to have an infrastructure that can enable test evaluations, okay, of vendor equipment, and to also work with academia in such a way that the academia, the protocol, the new mechanism that has been developed in the open source environment can also be tested in a commercial equipment, right? Because what the academia develop in terms of protocol mechanisms, also we are follow the specification 3GPP on the Uran Alliance. Then anything that we develop should work in a commercial equipment, component equipment from the industry as well. Then for this, the CCI XG Testbed has been assigned as an open test integration center in the Washington, D.C. metro area. I will talk more about this later. Also, is missing the slide, the CCI XG Testbed is part of the Accord project, okay, that I have a separate slide and talk about this later. I'm sure that Trace for ATT has already talked about Accord. Mary from West Ignite also has talked about Accord. Then I will talk briefly in the end of this presentation. And not at least, also the CCI XG Testbed, we work very close with the open source community. And a good example of this, the CCI XG Testbed, we host the first SRS North America lab inside of our OTIC center and also the indoor laboratory in Washington, D.C. metro area.
Something else like that?
Yeah. Let's talk a little bit very quickly here about the CCI Testbed experimentation. What are our contributions? What we have been doing so far, right? The CCI Testbed is developed in true scenarios, indoor and outdoor. Okay, the indoor is a radio ceiling grid located in the Washington, D.C. metro area with 72 USRPs, next generation of USRPs. All of them connected to an OpenStack cloud environment that is accessible to containers and VMs. Our SDRs is not connected to bare metal machine, okay? Then we have an outdoor deployment that is a 3 rooftops deployment in Virginia Tech main campus and Blacksburg, what cover 1.5 mile corridor. Basically, this infrastructure, above indoor, we focus completely in end-to-end open source scenario where you have hardware, white box, and also soft open source, plus Uran commercial equipment. Today, we are working both with OCU, DU, RU, commercial, and open source. Also, we are well known to be the first testbed or network infrastructure experimentation to present an end-to-end closed-loop Uran software-defined radio base with non-real-time RIC, near-real-time RIC, radio access network with SRS run, and also close the loop with the AIML framework. We operate under the FCC experimental license, but also Virginia Tech is one of the few universities in US that hold the commercial spectrum for CBRS 3.5 and 3.7 gigahertz. We hold the PAL license. That is the, what you see in this map here is where right now we have building and continue to progress to build on-site on campus this CBRS private network to explore and use the CBRS spectrum that we have. I'm going to give quickly a couple of examples of experimentation and researches that we have been doing in the platform, this Uran platform. One of them is that we have this project here that is in collaboration between CCI XG Testbed and Samsung. Okay, in this project, we are the first testbed to integrate the AI/ML framework from the ORAN software community to a software-defined radio platform. And here you can see the architecture. We have been working with Samsung on this. We already have a prototype of this AI/ML closed loop. We have a demo that will be presented in the SRS Run workshop in October 1st and October 2nd. And the Samsung team will be presenting the demo there with us. It's very bad. Yeah. Another example that we have here is basically I have a student, an MS student, that has been working her thesis to create a scenario where we can test and validate XAP as a digital twins. In this case, this student is deploying XAP conflict detection mitigation using software-defined radio infrastructure.
I'm sorry, Aloizio, I think PDF would have been better, maybe just.
Yeah, I sent the PDF. The another example that we have here is the example 3 that we have been working in our testbed to implement and enable experimentation in 5G new radio unlicensed spectrum with OAI and radio frequency network on chip. This is part of a thesis of my students as well. We have a lot of results already that is not published. Right? But what I want to bring to the attention here today, that today does not exist out there, no hardware test bed that allow you to explore research and experimentation in 5G new radio licensed spectrum. And CCI XG testbed is bringing this to the reality right now because we were able to implement in this SDR level and the FPGA an LBT mechanisms, okay, and integrate it with OAI stack. I have an architecture here, but it's not showing. Now I am completely lost. The another sample of experiment is the
PDF somewhere. Yeah. I need the original PDF also somewhere.
Another example of experimentation that we have been doing also was part of an MS thesis of one of my students, is that the characterization orchestrator of E2 interface denial of service attack. In this, we create a malicious XAP, okay, and also we create SDR-based false base stations, okay, and we use both of these attackers, okay, to try to attack the E2 interface that connect near real-time RIC with the radio access network. And our finding was very interesting because the E2 interface that we have today implemented in testbed follow completely the URAN alliance specifications. And we find in our results that the E2 interface is not security at all, okay? And also we found out is that the following, by the specification of URAN alliance, the E2 interface, okay, only allow you to have a single E2 interface between near real-time RIC and the radio access network. What this means for us in terms of threat and security? If the E2 interface is on the attack, this means that the whole radio access network infrastructure can go down. This means that all your AI, ML, your intelligence that you have is nothing anymore, because you cannot communicate an RAP and XAP with the radio access network if the only path that you have is go through A1 interface to near real-time RIC and E2 interface through the radio access network. And then this student has implemented this. We have very interesting results, and we have this prototype as well, implement and software-defined radio.
I think I'm trying to download, maybe we just go through it, we'll see what we can do. There is another file.
Okay, much better. Yeah, I will not go in detail, but this is the architecture of the characterization orchestration of the E2 interface denial of service attack. It's very complex, but you can see that we have implemented everything using the ORAN software community, open source platform, non-real-time RIC and near real-time RIC. And we use SRS Run to create the false base stations, and we implement as well malicious XAP to attack near real-time RIC and also the E2 interface. mainly focused in single storm attack.
So, Aloizio, please take more time if you have to, because I think the one in the Google Drive was...
But I don't think this is work.
No problem. Yeah, just go back and forth. Please take your time.
Okay. The another example of experimentation that we have been using here, deploying the test bed, and this one is an interesting one because focus on enabling CBRS experimentations and machine learning-based incumbent detection using open source. Yes. We are one of the few universities that is based and applying research and prototype that has capable to develop what we call an open spectrum access system. And this open source, open spectrum access system is fully compliant with Win4 specifications. And we also have validated it with the Google SaaS. And in the left side, you can see the dashboard of our open source SaaS that we have implemented in-house. Okay, and this mechanism here is part of a thesis of one of my students as well, where he has developed mechanisms based in AI/ML that is able to do detections of ML incumbent in the network. And he has implemented this in the level of FPGA. Okay, I will not go to details here neither, but we create as well what we call the CBSD. The CBSD is a base station in CBRS. Okay, to create this prototype in CBSD, we developed it in prototype using a software-defined radio, USRP, X310 and N310. The full stack that we have used, we use SRS run 5G and TDD mode. And this today is operational, this CBSD, and also is part of our outdoor deployment in Blacksburg campus there.
Aloizio, if you have other slides that were not properly shown, please take time to talk to it. Not good if we cannot. Oh, you need the laser pointer?
No, I am. Yeah, then I have spoken about the experimentation part of the CCI XDS bed. I give you guys some example of very interesting, cool, and applicable research that we have been doing there so far. Okay, now I'm moving towards to the OTX Center because the CCI XDS bed, we also hold ORAN, Open Test Integration Center in the Washington, D.C. metro area. And our main focus in our OTX centers is focusing testing of conformance, performance, and interoperability testing. However, we are also injecting now, because it's a demand that is coming from the Accord project, we will be doing security testing. Okay, a lot has been said probably about Accords, but I just want to highlight in terms of the CCI test bed. And the Accord project overall architecture, okay, there are 2 satellite laboratories. And the other laboratories that is connected to these 2 satellite laboratories is well known as a neutral host. These two satellite laboratories are UT Dallas, okay, and CCI XG test bed at Virginia Tech. The CCI XG test bed in Virginia Tech hosts the satellite laboratory that is named Potomac, that stands for Platform for Run Testing, Orchestration, and Management with AI Control. Okay, as I mentioned before, we serve as the satellite laboratory from the Accord project in the Washington, D.C. metro area. What are the responsibilities of this Potomac laboratory that CCI XG test bed holds? We are responsible to provide an end-to-end setup for OCU and ODU open front haul testing, okay, for different vendors. Today, the vendors that has been integrated in the Potomac laboratory and the equipment is already there, they are now under testing, we are doing the pairing test between Nokia ODU and Fujitsu ORU. Also is responsibility of the Potomac laboratory to deliver in the end of the project of Accord project for NTIA for the government, the end-to-end open source SRS run based, okay, ORAN reference architecture. Basically, we already have this reference architecture. You have noted by the example that I gave and the experimental research that we have been doing so far. And also, the Potomac laboratory will serve as a nucleus for cloud-defined federated lab as a service for the whole neutral hosts laboratories that is part of the accord. Okay? Today we are interconnected. The Potomac Laboratory is interconnected to the Cosmos testbed. We are also interconnected to the Idaho National Lab. Okay? And we are also already interconnected with UT Dallas. The idea is to continue these cloudification federations inside of the Accord project with the other nuclear hosts. Yeah, this basically is my last slide of my presentation. I would like to invite you guys. I am hosting together with the SRS Run team in Virginia Tech Research Center and Arlington, Boston, Washington, D.C. metro area, and October 1st and October 2nd, the SRS Run Fall workshop. Will be a very technical workshop compared to the previous versions that we have last year, that will be very focused mainly on how you can bring the open source of SRS Run for the commercialization side, how you can use the SRS Run Open Run stack in the commercial, in the real deployment. And then I hope you guys can join us there on October 1st and October 2nd.
They were messed up. Did you get a chance to talk to it? Because I had a problem with the Google Drive and Box, so things in the Google Drive were okay, and then my apologies for that. And thank you, Sam, for fixing it. Yeah, you were able to go through any of the slides you missed, maybe? Just,
but this is not working either.
All right. Yeah. But there are a few slides, there are no pictures, right?
One more. Yeah, I think it's just the one with
okay. All right. So.
Yeah.
I just didn't want, if you prepared slides, there's so much of.
If you can go to the one with the 5G new radio, unlicensed spectrum. Yeah, this one. Yeah, this one that I just want to bring the attention, because this is something very new that we have been working very hard, and it's part of one of my student MS thesis that is defended now in September. What you can see here, we have implement in the FPGA level, okay, inside of the USRP, what you call the listening before talking. Okay, it's well known that the listen before talk nature is working very constrictive in regard to the time, that is 90 microseconds, right? Then it's very hard for you to implement the methodology, the business logic of LBT in a software-defined radio platform. But we were able to overcome this gap by implement this in the level of USRPs, and there are two building blocks that you are seeing there, highlight, and also implementing the stack of OAI. Yeah.
Yeah, excellent. I was amazed how many things you do. Any question, folks, from the audience? All right, so I guess it looks like you are really part of the whole ecosystem, plugged in different ways. And some of the questions Scott was asking before about the security, you're also doing some of those in your testbed. That's good to know.
We are starting to do a lot of about security first, because we are from Commonwealth Cyber Initiative. Then is by Commonwealth Cyber Initiative is an initiative from the Virginia local government. Okay, it's a $20 million fiscal investment to do research and workforce development in cybersecurity. And then to the testbed level, the folks that I have been working as a testbed director right now is very focused on Open Run and mainly trying to working towards the security as well, not just in terms of commercial, but more in terms of research also, and to test and validate the specification of 3GPP and analyze.
Yeah, that's great. So thank you again. Let's give a big hand to